You guys want to give it a shot? Yeah, you guys can do it together. Cool, cool. So it's two very easy multiple choice questions. So this is the first one. So I have 3 box trucks and they're completely sealed. They're all on a level surface and they all have an apple hanging from a string. The only difference between these 3 is that one is at rest, one is accelerating forward, and one is accelerating in reverse. So out of these 3, which one is at rest?
B?
Sure. Would you say B2? Or?
What was the third thing? They're accelerating where?
So one is at rest, one is accelerating forward, and one is accelerating in reverse. So
decelerate? Or
no,
so they're slowing down?
Not slowing down. So one is at rest. Yeah, one is reversing and one is accelerating forward.
Okay.
So which one's at rest? Which one's not moving?
B.
Okay, how did you guys know it's B?
Because the apple's moving.
Is it moving? Okay, yeah, pretty simple. Which one's accelerating forward?
This one.
Hey.
Okay, how did you guys know it's A?
Because it's going forward, so it has to go back.
Okay, sure. So due to inertia, it just remains motionless, you could say, and the container is moving.
Yeah.
So it just gets left behind pretty much due to inertia. So yeah.
Or it could also, yeah, it's probably A.
Yeah, it is A. And then obviously this will be reversing.
Yep.
It's the opposite, right? Perfect, you guys got it. So the second one, pretty similar, but instead of an apple, is a helium balloon inside. So out of these 3, which one is at rest?
Still B.
Still B.
Yes, and it's for the same reason as the first,
Yep.
because it's not moving. Which one's accelerating forward?
Still A.
A. Actually, this one is C. And there's 2 reasons why it's C. So the first reason is air is more dense than helium, right? So the second reason is a force. So as soon as I apply a force, for example, in this direction, accelerate forward, all of the air that's inside of the truck is also being forced in that direction through space. And because air is more dense than helium, is able to push the helium along with it. Does that make sense? Air wasn't dense enough to push the apple, obviously because apple is more dense than air, so the air wasn't able to push it along with it, so it got left behind due to inertia. This, however, the helium is less dense than the air, so it is able to push it with it.
Okay.
So yeah, so the helium balloon gets pushed by the air because the air is also being pushed.
Yeah.
So that's what buoyancy is. It's a chain reaction of a force. So here, I recreated this experiment inside of a cargo van with a helium balloon and an apple. Look at that. So what direction would you say I accelerated this?
Forward,
right?
forward.
Yes, exactly. Because again, matter doesn't lie. And if I was to tell you I accelerated in reverse, obviously I'm bullshitting. You know, I would be lying at that point. Yeah. And again, videos can be manipulated and obviously changed. So I have this experiment here in real life. So this is a buoyant object, right? The water around it is more dense than the ball. So if I would apply a force in this direction, what direction?
Go in that direction.
Yes. See? So that's physics, that's reality.
Crazy.
So buoyancy always follows the direction of the force. So one last question before you guys go. If I have a helium balloon here on Earth, right, because helium is buoyant, if I let it go, what direction does it go?
The way that the Earth's rotating?
Like this right now. There's up, down, left, right. If I have a helium balloon, what direction does it go?
Up.
Yes.
Yeah.
So there is 2 reasons why the helium balloon rises. So why do you think it rises?
Lighter than air.
That's the first reason. What's the second reason?
Lighter than air. That's not heavy enough for gravity to affect it.
Close. So the second reason is a force. So it has to do with gravity. So again, in this scenario, the truck generated the force to be able to push the air, and then the air was able to push the helium, right? What do you think is generating the force here on Earth to be able to push up the air, to be able to push up the helium?
The rotation.
Okay, you said the rotation, in fact, is actually the upwards push of the Earth. Have you guys heard of the normal force of the Earth?
Yeah, not the normal force of the Earth.
No, so the normal force of the Earth, you can look it up, it's a real force, and it's an upwards push of the Earth. So I know you guys heard of gravity obviously being a pulling force, right? I don't know if you guys knew a pulling force of gravity is just a theory. So it has never been physically measured or detected. So when you release an object into free fall, everybody believes that there was a force that pulled it down, right, to the Earth. In reality, what happens is when I release this into free fall, it's the Earth that's coming up to meet it. So everything is we're being pushed up right now by the Earth. We're not being pulled down to the Earth.
Oh,
so that's what we're stuck.
It's not moving in a straight line around the thing. It's going in a
So no. So the Earth, relative to us right now, is pushing up against you right now, and that's why we're stuck to the Earth, because the Earth is pushing up against us. It's not pulling us down towards it. Does that make sense?
Yeah.
Yeah, right? That's why we're stuck to the Earth, is because the Earth is pushing up. So that's the real force of the Earth. It's a push of the Earth, not a pulling force. So again, gravity is just a theory, again, to explain that why objects accelerate down, but in reality they don't, right? So here's a real reason why I'm doing this. You guys believe the Earth is a ball, right? Do you guys understand that on a ball, up is relative? So if you're standing here, up is this way, but if you're standing down here, up is in the opposite direction, right? And if you're standing here, up will be that way, right? So in every direction away from the center will be up on the ball, right? If we could prove that gravity is a push of the earth and not a pull, in other words, the earth is moving up, pushing up against you and not pulling you down, and buoyancy shows us that. If we could prove that, how can the earth move up, in other words, push up in every direction at the same time if it was a ball?
It wouldn't, because it'd be like falling apart.
Yeah, it would explode. It would expand and explode. So in other words, in order for people to believe in the ball earth theory, they first have to believe in the theory of gravity being a pulling force. Because if we could prove that it's the other way around and it's a pushing force of the earth, then the whole globe earth model falls apart. It wouldn't even work on paper. Because again, it would just expand and explode. It wouldn't work. So the reality is the earth is just an extended level plane and it's just pushing up in one direction. So everybody's up is the same. It's not relative. So China and Australia are just across the way. They're not underneath us. So the earth is just a level plane that's moving up in one direction. So that would be the number one proof to debunk the globe earth, is the fact that gravity is a push of the earth, not a pull. So that would be the number one proof. So if I was to ask you guys respectfully, why do you guys believe the earth is a ball?
Shots from space.
Okay, images from outer space. What else?
Stuff like if you're looking off in the distance, you know, you have a light through a hole, you can't see that light. There's a horizon.
So you're talking about like a laser experiment over a distance, shows that there's curvature.
Yeah.
Okay, so I'll talk about that first and then I'll talk about the images. So laser experiments, there's a reason why those are being pushed in the mainstream to prove the globe, right? What happens if I shine a laser through water? Will that laser go straight?
It'll diffract.
Yes, so it won't go straight, obviously, because of refraction. The atmosphere is basically moisture. So if you shine a laser through the atmosphere, guess what you're gonna have? Refraction. So you're gonna always have an inconclusive test. But there is a very simple test we can actually do to measure to see if there's curvature, and I'll show you. First, do you guys know the radius of the Earth that they tell us?
I don't know.
Okay, it's pretty simple. You guys can look this up. I'm not making it up. So it's 3,959 miles. That's the radius of the Earth, allegedly. Again, they claim to have satellites orbiting the Earth, so they need to know the radius of orbit if they're supposedly going around it. So they do tell us the radius. So based on the radius, we can calculate for the circumference, which is 24,901 miles, allegedly. But using a simple calculation like the Pythagorean theorem, a squared plus b squared equals c squared, we can literally use this calculation to calculate for how much curvature there should be every mile. And it turns out that there should be 8 inches per mile square of curvature. That means in the first mile is an 8-inch drop, second mile 32 inches, and by the third mile it should be 6 feet of measurable curvature, right? So how do we measure for that curve, right? It's very easy. So if we went to a giant lake that was 3 miles across, for example, and it was filled with water, if we build a level structure above it, like a horizontal structure above the body of water in 3 miles, the water is going to show that it's going to be parallel to anything horizontal above it, because the physics of water when contained and at rest shows that the surface always equalizes. It always forms a horizontal surface, which is level. That's where we get the term sea level, right? They're trying to tell us that the surface of a lake is bending 6 feet in 3 miles. So they're trying to tell us that if you went to a lake that was 3 miles across, that there's going to be a 6-foot deviation from the starting point and the end point of 6 feet, which is a physical possibility for water to be able to do that. Water doesn't have the ability to support a shape on the surface. It always takes the shape of the container, but the surface always equalizes and forms a horizontal. So they're trying to tell us that this is what physics is, but in reality, this is what physics is. So the physics of water shows that the globe Earth, is a physical impossibility. So this will be the number 2 proof to debunk the globe, a physical measurement of the Earth, literal physical measurement. Because laser experiments are again, they're going to get inconclusive answers. And that's why those experiments are being pushed. Because you're not going to get an answer from it. A physical, literal measurement like this will show there is no curvature to the Earth. And water doesn't have the ability to bend. Mm-hmm. Now, you were talking about images, right? Images from outer space. So if I show you guys an image or even a video of me walking on water, would you guys believe I could do that? Why wouldn't you believe me?
You're denser than water.
It defies physics, right? So if a magician did that, I know automatically it's a trick. So I'm going to figure out how he did it, not the fact that he could do that. Because that defies physics, right? Even walking through walls, for example. If I showed you a video of me walking through walls, obviously it's a trick. Like a magician's trick, right? That defies physics. The globe Earth images and videos defy physics as well. Water doesn't have the ability to bend around and stick to a ball. Especially if the Earth is pushing up. That wouldn't make sense from a globe. How can the Earth push up if it's a globe? It can't. So again, these are the two proofs that debunk the globe Earth without a shadow of a doubt. It's the physics of water, because the Earth is covered in water, the oceans, and they show that they're level. And the fact that gravity is, again, is a push and not a pull also debunks. So again, obviously images shouldn't be trusted, especially if those images defy physics. And here's another thing. NASA admits they don't have real images of the Earth. They openly admit they're composites. Yeah. So how ironic, right? They say that they do that because they can't go high enough to take a picture of the whole thing. So they just literally make it in Photoshop. But then that contradicts the fact that they went to the moon in 1972 and all that. Obviously that was all made in a studio. If you look at the footage from the moon landing, it's laughable. You know, it's pretty pathetic. Like the moon landing footage. You know, is there anything else that convinces you that it's a globe Earth, or are you guys open to the idea that maybe we have been right too?
Maybe.
When we have telescopes, we see that the planets are circular.
Okay,
shape.
sure. So telescopes from NASA, obviously, again, they show us CGI, but if you have like a very powerful zoom camera, optical zoom, you can zoom into the stars. So these are what the stars actually look like when you zoom into them. So nobody knows what they actually are, you know, but the fact that you're able to zoom into them like this and they look like they're rippling in water and change colors, you know, that shows me that obviously they're not far away and they're not terra firma. They're not other Earth-like planets. And this is what the planets look like. So this is what NASA shows us Mars looks like, but this is in reality what it looks like. So it's no different than what the stars look like. They just have their own unique paths. The only difference between planets and stars is that planets have their own unique paths. All these other stars are fixed. You know, they're constant. That's why they're constellations. But nobody knows what the lights in the skies actually are and where they're, you know, how they're being illuminated, I guess you could say. But to claim that these are Earth-like planets and that proves the Earth is a globe, that's a red herring. That's completely irrelevant. Looking at the sky tells us nothing about the ground we're looking at. You just have to make assumptions. So an assumption is not scientific, obviously. You know, a scientific experiment will be a physical measurement.
A lot of science is based off of assumptions. Like,
then that's not science, I would say.
No, it's because they have to make an assumption and then work back from it to get their answers. That's usually how things are progressed.
Yeah, I get that. So you could have a theory that's based on practical physics, for example, and you can build a theory off of that, and then you'll come to the conclusion that if that theory was true, you know, obviously it'll be shown to be true. But if there's something else that contradicts your theory, then you'll be able to catch that. You know, because again, if something is a theory, it hasn't been proven. You know, in other words, it's still up for investigation. The fact that the physics of water when contained in the reds shows a level surface, that's not a theory. That's physics that directly contradicts the globe Earth. Now, looking at the sky and pointing at the stars as some kind of proof for the globe, again, it's just a red herring. It's a false argument. So again, the stars have nothing to do with the dimensions of the Earth or the ground we stand on. You know what I'm saying? It's kind of like a scapegoat type of thing that people try to do, you know, type of thing. But you know, I get it, you know. That's what we've been told and shown, you know. Have you guys heard of Euclidean plane geometry or Euclidean geometry?
I don't know what it means, but I've heard.
So it means, so all the blueprints and construction that we do here on Earth, so when we lay down railroads or build tunnels, for example, they're all, the engineers use Euclidean plane geometry, which is planar geometry, which means everything is built on a horizontal surface. So nobody takes the curvature of the Earth in account when building bridges or anything on Earth. Nobody takes account of the Earth's curve. So all the blueprints, everything shows plumbs and levels. So verticals and horizontal lines, regardless of distance. So here's another thing. In engineering, all plumb lines are considered parallel to each other. You know what a plumb line is? No. A plumb line is a true vertical. So if you have a string and you tie a weight to it, that gives you true vertical, right? That's a plumb line. So in engineering, all plumb lines, regardless of distance from each other, are considered parallel. You know what parallel means, right? So on a globe Earth, plumb lines are not parallel because all plumb lines should converge to a center point, right? Because they're claiming the surface is not horizontal, it's curvy. So plumb lines converge on a globe Earth, but in reality, they don't converge. All plumb lines stay parallel because we live on a level, we live on a horizontal surface. So if you're standing here with a plumb line and you're standing here with a plumb line, your plumb lines are parallel, right? On a globe Earth, if you're standing here with a plumb line, but if you're standing here with a plumb line, those two plumb lines are 45 degrees from each other or 90 degrees from each other. So that defies physics. Nobody's ever measured or observed that. You know, everything practical here on Earth shows that the Earth is a level plane that's pushing up, not pulling, not a globe that's pulling you down. So they just inverted the physics with the globe Earth. That's all they did. Instead of us being pulled down, again, it's the Earth pushing up. And that's why we're stuck to the Earth. Yeah. You guys have any other questions for me about this subject?
No.
So before you guys go, I know you guys heard of flat Earth, right? So I'm going to give you guys a huge tip. So over 99% of flat earthers, especially online on YouTube, content creators, are all bullshitters. And the reason why is because they deny the upwards push of the Earth. So all of these flat earthers online, they're all motionless flat earthers. So they completely deny the normal force of the Earth, which debunks gravity. They're actually defending gravity, in other words. Ironically, they come up with their own explanations to how gravity, they don't call it gravity, they call it other things that accelerates matter down. You know, everybody believes this goes down. But in reality, it's just being left behind, and the Earth is just catching up. So the Earth is the container. We're inside of it. So just like with the truck, the apple gets left behind, and then the back of the truck hits it. If you were to turn this vertically, it's exactly what the Earth is doing. So the Earth is moving up, and this is like the apple, it's just being left behind due to inertia. So this doesn't have a force acting on it, accelerating it down. It's just inertia resisting the upwards push because the air's not dense enough to push it. Because as soon as I let it go, the air's trying to push it up, but obviously the air's not dense enough. Like a helium balloon, on the other hand, you release it, and it is able to push it up. Because that shows you that air is being pushed up as well. You know. So again, there's no denying that. So I kind of got through this whole thing with them. Here,
I've got to go eat.
Yeah, no worries, man. You guys take care. Yeah, here, take this. You guys can check it out. Yeah, you guys can share it. Yeah, all right.